Now, this first one is a great example of how to determine whether or not something is prime. So you're looking for two numbers that multiply together be 28, add together be negative 3. Since you have a positive 28 product, the two numbers had to be the same. Since you have a negative 3 sum, it means they have to add up to negative 3. There are no two numbers that will do this. So number 17 is prime. On your test, there is one, possibly two, that are prime. If you write prime more than once, you are probably losing points. Just putting that out there, just as a casual note. Prime is very rare. So rare. Alright, don't put it on a whole lot of problems. It's not the answer. Looking at these, this is going to be a add up to negative 18, or add up to negative 7, multiply to negative 10. This gives us p minus 9, p plus 2. Again, if you ever are concerned whether or not your answer is accurate, FOIL it back out. Like in this case, I'll get p squared plus 2p minus 9p minus 18. You'll notice that I get that same answer back. So if you're ever worried, do I have the right answer? Do I not have the right answer? Just factor it back out. If it matches, you did have the right answer. If it doesn't match, something went wrong. On this one, we'll have, how's this one going to work? We're going to go 2k minus 5, and then 2k, it's a k, not an x, minus 1. That'll be how that one works. 2v minus 3, v minus 1. Again, several different ways. I showed my class a factor by grouping. Some of you guys have used universal method. Some of you are doing it the same way I'm doing it. It's all how you're most comfortable. The end result, though, should always be the same. You should have these two factors. For solve by factoring, you're going to get here, you're going to get x minus 9, x plus 6 is equal to 0. So x could either be positive 9 from here, or x could be negative 6 from here. Both answers are accurate. Add the 3 to the other side. You're going to get 4n minus 3, n minus 1 equal to 0. And then n could be either 3 over 4 from this one. Remember, if you ever get confused, you set that up and solve. Or n positive 1 equal to 0. Would make this part 0. And you finish it off. Add the 1 to the other side. You get 7k squared minus 8k. Plus 1 is equal to 0. So you'll get 7k minus 1 and then k minus 1 equal to 0. Your two answers will be 1 over 7 and positive 1. Negative 63 going to 2, so I've got y minus 7, y plus 9 equals 0. So y is going to be positive 7 from here, or negative 9 from right here. Either answer is fine. Factor by grouping on number 25 and number 26. You grab the first two, factor out what's in common. In this case, it's a w. You grab the second two, factor out what's in common. In this case, it's a 6. And then we factor it out normally, just like we would with anything else. Oh, we're having some, there we go. Factor out normally like anything else. I have w plus 6 of this quantity, w minus z. Right here, factor out what's in common. They both have a c. It leaves me with a plus b. Factor out what's in common. They both have a d. That again leaves me with a plus b. We have c plus d up in front, a plus b in the back. 27, we have two perfect squares. 4y squared minus 169. That's going to give us 2y minus 13, 2y plus 13. On this one, you again have, it's a pattern one. It doesn't matter how you do this. I will teach my class the factor by grouping. Again, if you use universal method, you can do it that way. But you're going to end up with 3x plus 2y squared. And as always, if you're ever, did I get the right answer? Did I get the right answer? You can FOIL this back out. I'll show you that again. We have 9x squared plus 6xy plus 6xy plus 4y squared. And these two will combine to give you that nice little plus 12xy in the middle. And you can always check that answer and make sure it's accurate. Looking at number 29, factor out what's in common first. These have a 2k that is in common, and we'll get a 9k minus 4. Perfect square minus a perfect square will follow this pattern. We have 3k minus 2. 3k plus 2, and this one will give us three answers. 2k could be 0, 3k minus 2 could be 0, and 3k plus 2 could be 0. Our three answers that this will give us: 0 for this one, 2 over 3 for this one, and then negative 2 over 3 for my last one here. Factor out your polynomial first. I'll get 7p minus 2. Oh, is that plus 2? Yeah, that's going to be plus 2. And then p minus 5. You'll get two answers. P will be positive 5 from that answer, or that's a 1 PS. P will be 1 from this answer, or P will be negative 2 over 7. And I'm just having trouble writing today. Negative 2 over 7 for that last one. And if you ever get confused, again, how to get that: 7p plus 2 is equal to 0. Subtract the 2, divide by 7p is equal to negative 2 over 7. Looks just like that. Next one. These are the most confusing because you're already at that last step. It's already factored, ready to go. You could have x be 0, or you could have 5x plus 2 equals 0. In this case, x is 0. And in the other case, x is negative 2 over 5. However you want to get to that. But this is the final step. You're ready to solve right here. So don't let yourself get confused by that. Number 32, they've all got a 2 in there, so I'm going to factor that out. 25 equals 0. Factors of 25 that add up to negative 10, so v minus 5, v minus 5. Many of my students like to write this answer twice. You'll get a v equal 5 on both of them. It is only necessary to write it once. You don't have to list it twice. And that is page 2. Be very careful, and as always, if you ever get confused if your answer is correct or not, factor it out, and you will show whether or not it's correct.